Thank you. So I think I'm the last person before lunch, so don't worry, I'm not going to take too long. I'm not the last person before lunch. Okay, we've got a panel after me. But I'm going to be talking to you today about tracking for augmented reality. But before I do, I wanted to have a look at something. I wanted to talk about Pokemon Go. Now, I appreciate that this might have been hyped up last year, but I honestly don't think people are talking about it as much as they should be. And to start off with that, let's just have a look at some of the statistics behind it. So in its first month, this game generated $200 million. It's now generating about $2 million each day. In the days following the launch of Pokemon Go, the company that owned Pokemon Go went up by $23 billion. There are now these applications that have less daily average engagement than Pokemon Go, and that also includes Tinder, so you can see where people's priorities lie. Now, the promise of augmented reality has been around for several years. We know where we want it to be. We know that it's going to be used by doctors to help with their training and their procedures. We know it's going to be used by engineers to help give them understanding of systems that they've never experienced before. And in time, it will be used by each and every one of us to replace the mobile phones in our pockets and the computers on our desks. But the distance between where we are today now and that being a reality is still several years out. So I thought it might be fun to have a look at what are the barriers to augmented reality today, and what might Pokemon Go 2.0 need in the future in order to succeed. So to start off, we heard a little bit earlier with a few other talks about the need for something which is portable. The need for something that is able to be worn on your head, a head-mounted display that we can carry around. Now, we've seen what the beginning of portability was like for mobile, and actually there's a video that I want to show you which shows you some kind of portable augmented reality system. Let's have a look at this. Now, this was about 10 years ago.
With a head-mounted display and various sensors which we have, which is sensing my body's position and as well as the head orientation. So we know exactly where I am and what I'm looking at. So when we do this, we can then augment the real world which I am in now with the virtual world. So this Pac-Man world, I'm seeing it as part of the real world. I can see cookies in front of me and I'm walking through them as if I'm the human Pac-Man. So what we're aiming for is that we're going to taking the human Pac-Man and bringing it into more mobile devices. Within 2 years, we'll be able to see full commercial human Pac-Man type games on the mobile phones.
So is the time right for a human
This is what we want to try to avoid, okay? This was admittedly a portable AR system, but it doesn't really live up to our expectations. There needs to be something with a long enough battery life that we can wear all day and feel comfortable wearing. But in addition to just purely practical wearable purposes, it also needs to be ergonomical. This needs to be something that we can feel comfortable wearing out in public, in front of our friends. Okay, this is something that we're attaching to our face that we need to be able to feel comfortable with. Now, some of you remember the term people used for people who wore these Google Glass, these glass holes. And this was because it didn't really live up to expectation, and it distanced people wearing these devices from people around them. People didn't understand it, and they didn't really want to associate themselves with these tech gurus that they were seeing in the press. But you might also have seen the other company that's doing a similar job right now with Snapchat. Now, the best thing that Snapchat did, in my perspective, is they made their glasses look like something that could be picked up from the side of a shop from about £5. It looks so cheap. Okay, but actually, that was to its credit. This is something that you don't necessarily alienate yourself from your friends by wearing this on your face. And admittedly, this is only just a wearable camera at the moment, but perhaps this is one stepping stone between where we are today and Snapchat, or Snap, releasing a wearable head-mounted display. What else does it need? It also needs to have object recognition, genuine object recognition. These devices, these headsets, need the ability to look at the environment around them and to be able to react due to content inside their environment. Now, up until this point, for the past 5 years or so, AR, especially mobile AR, has relied on these markers, these fiducial markers. They're a little bit like QR codes. Now, phones are very good at being able to scan these, locate them, and be able to augment content on top of that. And again, I've got another video here that shows you we can actually do some interesting things with these. Let's have a look. Bear with it. I'm not using this to ridicule. I do think it is amazing, but wait and see.
Are you ready? Yep. Okay, go. Go.
Optimus Prime.
So this is impressive. It's not quite on the same level as the HoloLens that you saw earlier on today, but you know, we don't really want this. This doesn't really live up to our expectations of what AR can provide us. What we really want is something a bit more like this. What we really want is rich digital content that we can overlay onto the physical world. And this is something that I'm doing with my new company, and I'm excited to tell you about. We'll get into that a little bit further on. But first of all, let's just continue along the track about what we need with these head-mounted displays. We need the ability to have active pixel darkening. We need the ability, this means to shut out the real world, to avoid everything looking like a transparent hologram like Leia from Star Wars, Leia rather. We need to be able to shut out the real world. And we also need the ability to understand the environment around us. So I'm going to show you a video from Magic Leap and pay very, very, very close attention to when the digital character hides behind this chair leg. This is one of the first videos that Magic Leap revealed over a year ago now. So this is a digital object in the real world, and just pay very, very close attention in a few seconds when that character goes behind that chair leg. That's very, very, very hard to do. Very hard to do. And in order to do that, you need to know exactly where these devices are in the world, exactly where they are, down to the centimeter. Because how can you overlay content onto the physical world if you don't know where the viewer is looking from? And this is a little bit of a problem for augmented reality. It's a little bit of a chicken and egg scenario. So how can you figure out where you are in the world without already having an existing map of the environment? And how can you build a map of the environment without knowing exactly where you are? So in robotics, this is referred to or solved by something called SLAM, simultaneous localization and mapping. And this is something that the HoloLens is fantastic for. So in the HoloLens, it's got several different cameras and light emitters where it can spit out a UV pattern, then receive that UV pattern, and it knows that any change in that pattern is a result of shape in the world. So as you move around, it's figuring out what the world looks like and simultaneously figuring out where that device is. Now, this is great, and we can see this progressing more and more over the next few years, but it still has a few limitations. At the moment, I'm going to use an analogy of Command & Conquer. It's an old PC game, and in this game, you start off with an entirely black map, and you send your characters throughout this world. And as they wander through this world, they start to map out the environment, and then you can send your troops there. Now, with AR at the moment, it's currently like everybody's in their own little silos, mapping out these individual parts of the world. They can't communicate with one another. What we really want are these maps, these SLAM maps that are hosted in the cloud, that we can both feed to as well as recall from. So if you're a device and you've never visited an environment before, but another device has already mapped that out, you can recall that map. So you can have this kind of shared understanding, this shared memory of the environment around you. And you can also update that map based on changes that might have happened in that environment. Again, that's what we're doing at my new company. Now, what happens when you've got a very, very large map? Well, it becomes very hard to figure out where you are. You've got all this data to sift through. And actually, there's a fun game you can play. There's a website called GeoGuessr, which it will show you a single image that's taken on the sum of all Google Street View imagery. And you need to guess where exactly that image was taken from. It's really, really, really hard to do. Humans aren't very good at it at all. But last year, Google came out with a neural network, you can refer to it as artificial intelligence, that was able to accurately pinpoint where images were taken from. I think it was 10% of the time it was down to the city level, and 3% of the time it was actually down to the street level. So with the sum of all imagery, it was able to figure out where these were taken from without any GPS information. It's really, really, really stunning. But how can you make this better? Well, with neural networks, with artificial intelligence, the more data that you have and that you can provide it with, the better it will become. So some interesting things happen when you start to provide these with more data. So you might be familiar with the process of photogrammetry. So what you're looking at right now is not a traditional video as such. It's actually an animated 3D model that was generated using multiple different images that were built up together, triangulated to figure out, to build this very, very high realism three-dimensional model. And you'll see a little bit with this video just how that was put together. this model was created was in something like this. So a model walks in, performs a T-pose, and they're taken pictures of from multiple different camera angles. Now you can look at those different images and you can figure out where the corresponding feature points, and you can essentially triangulate where those feature points are in 3D space. Now this is where all the cameras are looking inwards. You can also do it where all the cameras are looking outwards. And as a little experiment, whilst I was doing some work with the company Rewind, we figured out what was the cheapest way that we could actually scan environments. And it turns out that you can use 360-degree imagery to perform this really quite quickly and easily. So this is just me wandering down St Albans High Street with a standard 360-degree camera. This would have cost about £250. Really cheap. And I'm just wandering down the road, okay? We take this footage, we separate that footage out into individual frames, and we figure out where are the corresponding feature points inside of these frames. From that, we can then make the map more dense. We can then make that map a mesh and then reproject the textures back onto the mesh. Now, I'm not using this to show you how great the visual fidelity of this mesh is. I'm just showing you that this map contains all the information we need to be able to make calls to that map, to figure out where a device is, and then we can send the device location straight back. So once you know exactly where you are, we can overlay digital content. You could be stood in the Colosseum. We send a keyframe up to a server where our localization is performed. We send the location back, and then we can show a reconstruction of what the Colosseum once looked like back to the device. And this is just with a standard mobile phone, any device with a camera. And here's a video of one of the maps we made recently of Piccadilly Circus. As you can see, it's not particularly high visual fidelity, but again, it's got all the information we need to be able to localize any device on a city scale. So this is what I'm doing with this company, Scape. We're working on city scale augmented reality. And please, if I can ask you to visit scapear.com. If you are interested in this, do sign up to subscribe to news alerts. And if you'd like to work together and figure out how we can use this, please come and talk to me afterwards. But for now, thank you very much.